What is tribology? Tribology can be defined as the science and technology of interacting surfaces in relative motion. It has a very wide discipline that not only limited to machines and improving industrial efficiency. Tribology has been involved in our daily life without realized by us. For example, biotribology that involve human joints, even with brushing our teeth in the morning, involve a lot of tribology studies. The tribology has a wide application and potential to be applied into many different areas. Its practices can be related to friction, lubrication, and wear. Friction is a tangential force generated between contacting surfaces that occur in an interaction between all real surfaces. It always acts in opposite direction to the motion. In most of the cases, friction is not desired, for example bearing and gears, but in some minor cases, for example brakes and clutches, friction force is desired to create a gripping force.
Wear is defined as the surface damage of one or all solid surfaces in contact subject to relative motion. There are several types of wears. The first one is the abrasive wear. It happens when the asperities of the hard materials cuts the asperities of the softer material. The second one is the erosive wear. The relative motion of solid surfaces with the fluid containing hard particles causes the erosion of the asperities of the solid surfaces. Next is the corrosive wear. It is described as the surface damage due to the chemical reaction in the environment. Then, fatigue wear is due to the cyclic loading. The surface will accumulate micro damages that breaks as asperities. Lastly, the adhesive wear happens when the transfer of asperities from one surface to another when they slide over each other.
Lubrication is the control of friction and wear by the introduction of a friction-reducing film between moving surfaces in contact. There are four types of lubrication principles, which are hydrodynamics, elastohydrodynamic, boundary, and hydrostatic lubrications. For hydrodynamic lubrication, it occurs when we apply a thick layer of oil, moving the block over the surface with high velocity. We can see a wedge-shaped oil film is formed between the block and the surface. Due to smaller cross-sectional area at the tailing end, this sufficiently increases the oil film pressure at the tailings end and carry the load of the block, thus reduce the friction. For elastohydrodynamic lubrication, it occurs if we increase the weight of the block. The pressure generated in the oil film increases, which deforms the block elastically. For boundary lubrication, it occurs if we move the block on the surface with a very thin oil film. Enough pressure is not generated in the film due to which contact takes place between the block and the surface. This is also called thin film lubrication. For hydrostatic lubrication, it occurs if some external pressure source is used to maintain the film pressure between the block and the surface. Thus, there is no contact between the block and the surface. This is mostly done in a low velocity condition.